This is a waste-to-energy plant. It looks like a typical industrial building, but the process going on inside is quite special. A waste-to-energy plant converts our rubbish into electricity. Some plants supply heat to district heating systems too. How does it work? The most widely used technology takes waste and burns it. The heat created is used to make steam, which in turn drives a turbine that generates electricity. The technique we're going to look at is widely used around the world. You'll notice that all the plants are very big. This is a process that works best on a large scale. Incinerating waste creates emissions and residues, and part of the process is focused on dealing with these. Achieving a high rate of efficiency with a low volume of byproducts is the aim. There are many systems of varying complexity, but they all work on the same principles. To set up this kind of waste-to-energy system, you need a stockpile of waste, a furnace, a boiler with heat exchangers, a water supply system, a turbine, and a generator. The waste is collected and delivered to the plant, where it is stored in large bunkers. It's transferred from the bunkers to a chute, leading to a moving grate in the furnace below the plant's boiler. The temperature in the furnace is very high. The gases in it are heated to over 850 degrees for at least 2 seconds to make sure all the waste gets burned completely to form stable end products. The residue left behind is called bottom ash and is non-hazardous. It's usually sent for recycling and is often used by the construction industry. Around 20% by weight of the waste ends up as bottom ash. The intense heat from the furnace rises into a series of chambers in the boiler. The idea is to capture the thermal energy as efficiently as possible. In the boiler are heat exchangers, a series of pipes filled with water, a bit like a household radiator. The heat vaporizes the water to form superheated high-pressure steam. This is sent to the turbine, where it encounters a series of turbine blades. The high-pressure steam forces the blades to rotate at high speed, driving the generator in order to make electricity. The electricity is fed to the power grid for use by industry and the local community. Water travels through the system in a closed-loop cycle. After passing through the turbines as steam, it is allowed to condense and is then returned to the heat exchangers to be heated again. Some waste-to-energy plants incorporate a district heating system into the cycle. The low-pressure steam from the turbine heats a second closed water loop, leading out into the community, where it in turn heats individual systems. Gas emissions from the boiler are known as flue gas. Flue gas must be treated before being released from the plant's chimney stack. It's processed using a series of absorption, scrubbing, and filtering systems. There are 2 other types of waste product. The first is the wastewater that wet flue gas treatment plants produce. This is treated, then released. The second is fly ash, which contains toxic chemicals and consists of solid particles in the flue gas. Fly ash is sometimes treated, sometimes not, but either way it must be disposed of as hazardous waste. Fly ash represents less than 5% of the waste input of a waste-to-energy plant. Waste-to-energy, or energy from waste, technology, is continually under development. Today, the most advanced plants using the technology we have described are up to 98% efficient in capturing the energy they generate. However, there is debate about the effects on health of incineration and its byproducts, and about the CO2 produced. The UK and the EU have stringent controls on emissions, and all emissions and residues are monitored closely in the UK by the government's Environment Agency. There are various other forms of waste-to-energy processes. Some examples are gasification, which produces combustible gases, anaerobic digestion, which produces methane-rich biogas, and pyrolysis, which produces bio-oil. Investment in waste-to-energy plants does depend on our continuing to produce burnable waste, which some might see as an incentive to create it. There is also debate about the indirect environmental impacts of making biofuels. Whatever the process used, the objective is to reduce volumes of waste, in particular to send as little as possible to landfill. The UK government estimates that waste-to-energy processes will account for 25% of municipal waste treatment by 2020. Waste-to-energy technologies recover value from our waste and are therefore a source of renewable energy.